And let's power it up. Okay. Looks like it has some life to it. Well, I tried hooking up this generator, which we know works because it can drive the speaker. And it seems like no matter what I try, I can't get any type of a reading to happen over here on the display. I'm pretty sure I'm using this correctly. I have the function switch in frequency. There are other modes here. There's period, period average, and then there's events, CL and OP, it looks like. So I want frequency, and this should act as a regular frequency counter. It should respond to the input. Time base is basically just what range I want it to operate in, and it doesn't matter what range I put it in. I can't get it to, again, it doesn't do anything. Changing the frequency here doesn't do anything. There are 3 inputs. They appear to be different inputs depending on the frequency range. So this one up here to the right says 250 megahertz. This one says 1 gigahertz. And then this one over here says 1 megahertz. So I'm assuming that for the low frequencies, I would want to use this one. The generator I'm using is a 20 hertz to 2 megahertz generator. So for most of the range of this generator, I would think this would be the correct input. Attenuation, it doesn't seem to matter what position I have this in. This should be the input sensitivity. And again, nothing seems to make a difference. This input switch appears to be to select which one of these 3 B and C inputs you're using. So I've got this in the correct position. And I've even tried using the other inputs and seeing whether or not there was any action through those, and they all seem to be dead. So I'm pretty confident that the frequency counter is the issue. I even double checked this to make sure. You know, I still have signal coming out of the generator, and this thing's just doing nothing. So I think this is a sick frequency counter. Before we move on, let me show you something I found interesting. If I put this over into the events mode, the one that says, I think it says OP, it counts. And not only does it count, but the speed at which it counts is directly related to the frequency that I'm inputting. So if I lower the frequency, you can actually see it slowing down. In fact, if I actually put it in a mode much lower frequency, I hit the reset, you can actually see it counting quite slowly. And now I'll reach over and I'll turn up the frequency on the generator, and you can see the rate at which it's counting speeds up. So that tells me that it is getting an input from the generator, and it's able to count the pulses coming out of the generator. But when I flip the mode over to frequency, I think this should then automatically just, I would think it should display the frequency, and it's not. And it doesn't matter what mode I put this range in. If I put it on a range and I change the frequency, that number's not changing. So I don't know a lot about how frequency counters work, but if I were a betting man, I would say that the reference oscillator is not working, because I think the reason why it works as an event timer or an event counter is because it basically doesn't need a reference to do that. All it does is sit there and count how many times it sees a pulse. And the sine wave frequency going in there is acting like a pulse. Well, at least that's what the counter sees it as. But for the actual measuring of the frequency, or to show the period of the frequency, it needs to make a comparison to a reference frequency. The reference frequency inside this frequency counter is housed inside of a crystal oven in order to guarantee that it's a very stable frequency that doesn't change. And that's this device back here, this little metal can. I believe this is the crystal oven. It says right on it, it's got a Heathkit part number, and then it says frequency is 4000.000 kilohertz. And the reason why they don't just say 4 megahertz is because they want to show you that this is a very, very precise 4 megahertz frequency. At least I think that's why they write it out really long like that. So if I were a bet man, I would say that this oscillator is probably not running, and that is probably why this thing's not working. So interesting. On the back here, there is another BNC connector that says output/input oscillator. And there's a switch that says external or internal. And I believe what this switch is for, and this input-output is for, is if you put this on the internal position, the 4 megahertz clock output can be measured right here. And if it's on the external position, I believe this acts as an input to input an external clock to sub the 4 megahertz crystal oscillator. So I'm not surprised it's not working right now, because I've got this in external position, so there is no... I'm assuming that when you put it in external, it probably disables that internal clock, or that internal crystal oscillator. If we're lucky, we just flip this to internal, and maybe the thing will work. All right, I come back around to the front here, and it's displaying something, and it may very well be actually reading the frequency of the generator. Let's see, I've got this on kilohertz, so right now it's saying that that's like about a 1 kilohertz signal that's coming out of the generator. It's very low on the speaker, so it's hard to hear, but that might be a 1 kilohertz. Well, let's just turn the control on the generator here and see. All right, let's see what happens. Yeah, see, oh, well, wait a minute. Maybe it's just counting very slow because I changed this setting. There we go. This controls the rate at which it's sampling the incoming frequency. Yeah, it's actually appears to be working now. All right, so the top of that range is at around 2.5 kilohertz, and I am on the times 10 range, so 200. Yeah, that's about right. So let's see if I put this in the lowest range. Oh, I've got this on kilohertz, so yeah. All right, put this on hertz. Let's see, 21.3. That might be correct. 28.9. I believe that is also correct. Notice I'm not surprised that this isn't lining up exactly. So when I put this on 30, for instance, well, that's weird. See, why did that just go up? All right, that's 100. Let's see what happens. 82.6. All right, let's crank it up to the 200. Wait for it to count again. 226. This might be working. How accurate? Not sure yet. I mean, this generator might not be putting out exactly... I think I'm more likely to believe that this is working correctly than this. This is working, but I don't think this is very accurate as far as the scale goes here. All right, so now I'm going to bring this back down to the low end here, and I'm going to bring it up to the times 10 range. So 20 times 10, now that should bring us up to about 2,000 hertz. Let's see, now that's saying 216. That doesn't seem right. Well, that does make sense because I'm at the bottom end of the range here. So that should come back to about 222. This should be around 300. 332. This should be somewhere around 1,000. 1030, that'll work. And if I move to the kilohertz time base to the kilohertz setting, that should be around 1.2 or 1.3, right? There you go, 1.2, 1.3. That should be around 2. There you go. That seems to be working correctly now. So if I bring this all the way back down and I go up to the next range, there we go, 2.2. There we go, 3.3 kilohertz. There's 2 kilohertz settings, so this must be, it's going to probably move the decimal point. There we go, yeah. This thing's actually working. Let's go to about 50 kilohertz, 58 kilohertz, and 100 kilohertz or so. That'll put us in the ballpark of, that should be about 1 megahertz right there. So I can go to the megahertz and I should get about 1 point something. Oh, I'm not in the megahertz range. That's the next range up. I'm sorry. This is 100 kilohertz. This is going to be our max. This generator actually is able to output about 2.4 megahertz, but they're saying on the generator that it's a 20 hertz to 2 megahertz. Probably what happens after 2 megahertz, it's probably not very stable, or the output drops off. So they're probably basically saying, hey, yeah, you know, it doesn't just shut off at 2 megahertz, but we're saying 2 megahertz is where the cookie starts to crumble. So there we go. There's 2 megahertz right there. We've got a working frequency counter. Cool beans. And this last piece of test equipment is something I actually picked up when I went back looking for the cord for that frequency counter. There were a whole bunch of bench DVMs there, and somehow I missed this one. It was off. It was in a different cabinet or off to the side or something, and I spotted this one, and it caught my eye, and I thought this might actually be worthy of saving. This is an HP Hewlett-Packard 3478A. Interestingly enough, this actually is marked Acton, so this must have been in the Acton, Massachusetts plant or lab. And it says Tektronix. And it actually has an ID number, almost like an inventory number, and a date. It says September 2014 was the calibration date, and that it was due for calibration on 2015. So that's actually, as surplus equipment goes, that's not that horrible that this was actually calibrated about 5 years ago. Well, closer to 6 now. But, you know, it's also been sitting. But the question is, does it work at all? So there are no feet on this thing. Let's see. Self-test, okay. Well, that seems to bode well. It's going a little crazy here, but I'm not that surprised because apparently it's in MVDC. That's millivolt of DC. So let's see. If we select DC, if we change the range, how do we change the range on this thing? Range / ended. Okay, range. All right, so there we go. So now I've gotten out of the millivolt DC range, and I'm in the regular DC voltage range, and it's showing 0 volts, which is what I would expect. Hey, let's get some meter leads. All right, so this is some kind of a real fancy schmancy laboratory grade meter that is capable of doing 2-wire or 4-wire measurements, and I don't exactly recall how that works. I think it's more for resistance measurements, where you actually have leads in parallel with each other. So I think if I want to just measure plain old DC voltage. I think I use this side here that says input 2 wire. And there doesn't appear to be polarity, but it's showing me the voltage symbols. So I've just got a little 9-volt transistor battery here that I had sitting on the bench with this clip on it. I don't even know if this battery's dead or not. Well, apparently it's good. 9.0681. It's actually maybe a little bit low for a no load, but that's not a brand new battery. See, it's got some other features here. There's a switch over here, terminals front or rear. So if you wanted to have this permanently set up monitoring some piece of equipment, you could hook the wires up just to the rear terminals, I guess. So that's kind of neat. Of course, this would be AC voltage. So let's see. If I want to do just a regular resistance measurement with just the 2 probes, I guess I would do 2 wire. Okay. OVLD, overload, meaning it's out of range. If I short the leads together, this should. So it's showing 0.3071. That's basically, it's reading the resistance of the actual wires themselves. If I hold this, it should be able to actually measure the megohms of my body. So I just pressed this auto manual button to auto, and it went right to megohms range because it's an overload. But now if I hold the leads, you can see it's measuring the resistance. It's picking up through my body, which is inconsistent because as the surface of my body, you know, perspiration, oils, and things like that will change that resistance. But you can see it's picking up 8 megohms or so and dropping. So real cool. This seems to work perfectly fine. Boy, I might have to keep that one for myself. So what's a meter like this worth on the used market, you might ask? Well, not a heck of a lot. A very small fraction of what it probably cost when it was new. Here's one sold for $55 with free shipping. And I did check the description. They're saying, you know, it doesn't come with probes or the cord, but it appears to power on, and they did test voltage, but it's not calibrated or anything like that. This one, same thing, $33 plus 27 shipping, so that puts you back up to around, you know, around 55 bucks. 45 bucks with shipping, around 60 bucks. You know, so we got a good sampling here showing us that this meter is worth, you know, somewhere around 50 or 60 bucks. And you don't see too much changing from there. This must be one that was really clean or something because it was 80, 85. That's it. So, not going to break the bank. It's kind of a cool meter, so considering that it's not going to make me rich, I think I'm going to probably keep it. I decided before I close out this video, I'd go back and revisit these other frequency counters and just double check them, since I already had the generator on the bench with the BNC connector. And it does seem to be working. I'm noticing the frequency is not very stable. It was actually rising. It seems to be stabilizing a little better now. I think that might actually be the generator. I just turned it on. It's actually the next day. I started filming this last night. So I just turned the generator on not that long ago, and it's kind of cool down here in the basement. Well, okay, this counter also appears to work, but again, I don't know how accurate it is. It seems to be also drifting upward. I set this very gingerly at 2 megahertz, and after a few minutes it's gone up to, well, what's that? That's 4 kilohertz above. So, but again, I'm not convinced that that might be the generator, could be the counters, I don't know. Actually, I think, so the other thing I wanted to do is I wanted to see whether or not that function generator worked. So why don't I hook the function generator up and see. Well, guys, I got the old Tektronix up here on the bench, and I have not been able to get anything out of this thing from the output jack going right into the channel on the oscilloscope. However, interestingly enough, when I move But if I take this BNC connection and I go to the sweep output, lo and behold, the sweep generator is actually working. So let's see, I gotta trigger this. There we go. All right. So that's a good sawtooth wave. It's doing what it's supposed to be doing. And if I use the sweep rate knob here, I can actually change the sweep rate. So that seems to be working. So it appears like the frequency, the internal, well, see, that's a good question. If the oscillator wasn't working, how's it generating a sweep? See, none of this works when it's in the, when we're just using the sweep output. So the amplitude over here, the frequency, all of this must be for what comes out of this output here. There's also a TTL output. Nothing seems to come out of that either. And then this over here is an input. Now, I did notice when I move the frequency knob all the way down near the bottom there, you see right there, if I kind of just jiggle it right around that area right there, there's a little something going on there. Don't know what. Also get a little blip when I just switch from the waveform shape switches. So I wonder if we got a dirty switch or a bad connection in there. Here's what it looks like inside. Looks like some quality construction there. I'm gonna clean those sweeps, those waveform switches. They're real easy to get to. And this is a potentiometer. If I put this to pull for internally, there might be something there. We got something. It's ugly, but it's there. There we go. Well, that's acting funny, huh? I take it back. This might work after all. So this switch right here apparently has to be pulled out. Alright, so the center knob must be the offset. This outer knob must be the amplitude. Yeah, there we go. Alright. Thought it was the other way around. There's some funky sweep there. Whoop. Let's see if we reach the trigger here. There we go. There you go. That seems to be working okay. Try square wave. Maybe not. And again, maybe it's the trigger. Well, I don't know, guys. Like I said, I never really used a sweep generator before, so I'm not positive whether or not this is working okay or not. Seems to be doing something. So I guess we're going to close out this video right here. Hope you guys enjoyed this video, watching me putter around with this old equipment. I hope it wasn't too boring. If you like seeing this kind of stuff, let me know. I'll try and bring you some more old vintage electronics. Now we're going to call this a wrap. Take care.